Alright, this is Module 4, Linear Functions, Part 1, so we're just going to review graphing lines and inequalities. Equations of lines are typically written in slope-intercept form. That's the form you're probably most familiar with, and this is y equals mx plus b. Now in this format, you should hopefully remember that m represents the slope, and b represents the y-intercept. So if you know those things about the form of line, and you remember how to graph the line, then this should be a really good, easy review for you. Number one, we're just going to have three lines that are graphed, and we are going to identify the slope and the y-intercept, then write the equation. Now, in number one, b is where you start. We're on the y-axis. Now, you have to know where the y-axis is to find the y-intercept, and the y-axis is the vertical axis. Well, here, my y-intercept starts right at 0. The slope is your rise over 1. Now, you need to find two nice points in your graph. I usually use the y-intercept, and then another point that goes right through one of the grid marks. Here, my rise, I go up 3. Looks like I run over 1, so my slope is 3 over 1, which equals 3. Now, when I write my equation, it'll be y equals, I do m first, which is 3, then x, and then my b plus 0 here, so I just have to write y equals 3x. In number 2, my y-intercept looks like it starts at 1. The line is going down, which means you have a negative slope. Now, if I pick 2 points here on my graph that it looks like it's going through, looks like I go down 3, right? 1, 2, 3, 4, 5. Maybe I think I did 2/3 on your notes there. No, this one's a little hard to tell. So it looks like maybe I went down 2 over 3. We'll just do that. It's good enough. Down 2 over 3. And our equation here would be y equals my slope, negative 2/3, x, and plus my y-intercept of 1. Last line here, my y-intercept looks like it's at 2. Again, the slope is negative, and it looks like if I pick 2 points, I'm going down 1, right 2, so my slope is negative 1/2. And the equation would be y equals negative 1/2 x plus the y-intercept is 2. That should be pretty simple for you here. Second thing we're reviewing is graphing lines given an equation. So if I have the equation negative 3/4 x plus 5, the b is the number that's by itself. That would be 5. So you start your graph and on the y-axis at 5. The slope is the number in front of x, which here is negative 3/4. That means if I start at my y-intercept, I go down 3 boxes, right 4 boxes. It's always down or up or down first, and then to the right. Okay, and once you plot as many points as will fit on your grid, you can connect them with a nice straight line. Now number 2, it's not in y equals mx plus b form, so we need to solve the equation for y. To do that, I'm going to start by moving the 6x to the other side. I'll get 2y equals negative 2 plus 6x, and divide by 2. Here I'll have y equals, negative 2 divided by 2 is negative 1 plus 3x. Well, the negative 1 is my b. The slope here is 3. So I'm going to start at negative 1. Now my rise over run means I go up 3, right 1. Okay, you can fill in those points. And then you should have a positive slope and a line that connects them. Should look something like that. All right, the third one, I want you to try it on your own, and then you can always come back if you're not sure if you did it right or if you got it wrong based on the key and watch the video here. But go ahead and pause and try it on your own. All right, so let's try number 3. So I'm going to start by moving the 8 because I want to get y by itself. And I'll get 4y equals x plus 8. They're not like terms, so I just tag the 8 on the end. And then I need to get y by itself, so I divide every term by 4. That'll give me y equals, I'm going to leave that as x over 4 plus 2. So the y-intercept is the number by itself, the 2. The slope here is the number in front of x, which is actually 1 over 4. When I start at 2, my slope from that 2 is going to be positive. Up 1, right 4. And I'm going to keep that pattern until I have no more room left to plot points and connect them. Alright, hopefully graphing lines is pretty simple. The next page on the back is where sometimes we get a little forgetful. Horizontal and vertical lines. Let's talk about vertical lines first. It's a special line. Vertical means straight up and down. This vertical line right here cuts through the x-axis, right? It crossed the x-axis, which means its equation is going to be where it crosses the x-axis. X equals here 2. Alright, so if I go through the x-axis, the equation is x equals, and the slope of any vertical line is called undefined. For a horizontal line, that horizontal line cuts through the y-axis. Here's the y. And it cuts through the y-axis at 1, 2, 3, 4. So the equation for a horizontal line is y equals. The slope of any horizontal line is equal to 0. Alright, let's try a couple on your own. You can always come back and watch the video. Go ahead and pause, see if you can find the equation and the slope of the following lines. Alright, number 1, the equation. Well, it's a horizontal line, which means it goes through the y-axis. So it's going to be y equals, and it looks like it crosses the y-axis at -4. The graph's going by 2's. The slope of a horizontal line is 0. For number 2, this graph is vertical. It's going through the x-axis, so it's x equals, looks like at x equals 7. The slope of a vertical line is undefined. Alright, x equals -7. That's a vertical line. So I go to x equals -7 on the x-axis and draw a vertical line there. The slope of a vertical line is undefined. Alright, and finally y equals 9. I'm going to the y-axis at 9 and drawing a horizontal line. The slope of any horizontal line is 0. Alright, let's finish this review up with graphing inequalities. When you graph inequalities, these are the ones that not just have a line, but have a dotted or a solid line and a shaded region. So, when you are working on these here, when I have a less than symbol, that's the first symbol that I see here, we're going to use a dotted line to make our line, and the less than means you're going to shade down or underneath that line. For the greater than symbol, you're also using a dotted line. They're strict inequalities. But the greater than, you're going to shade above or up over the line. For less than or equal to, when there's a line underneath, you're going to use a solid line. And you're going to shade less than means down. And finally, for greater than or equal to, you're going to use a solid line. And greater than means you're going to shade up. So use those to help you pick what you're going to do in each of these problems. The first one here, 2x minus y is less than 5. I'm going to solve this for y so that I can graph it. So I'm going to start by subtracting 2x. And I'll have negative y is less than 5 minus 2x. Then I'm going to divide everything by -1 to get the y by itself. When I divide by a negative, remember we did this in module 3. You have to flip the inequality sign. Then your equation will be -5 plus 2x. Now to graph this, I start at -5, that's the y-intercept, and my slope is up to right 1. So I want you to take a minute and plot your points. Now when I plot those points, this is a greater than symbol, which matches the second one here. I'm going to use a dotted line, so go ahead and connect those dots with a dashed or dotted line. And then I'm going to shade above for greater than. So shading, you don't have to be pretty about it. Just go ahead and scribble up there. That's your solution set. That means any point that is in that shaded region is considered a solution to the inequality. Now if I have x is less than or equal to -6, that's going to be a special line, just like we did up above. I only have an x, that's the only variable, which means I'm going to cross the axis at -6. Less than or equal to symbol is the third one here. That uses a solid line, so I'm going to draw a solid vertical line at -6. Now less than, I know it says over there to shade down, but for a vertical line, we have to think where the numbers are less than -6. Looks like the numbers to the left of that line are less than -6, so I would shade to the left. All right, try the next couple on your own, then you can come back and check the video. Okay. So number 1 is already y equals for you. So I'm going to go ahead and plot the points at -2 is where I start. My slope is up 3, right 1. So I plot those points, and now I have to decide what kind of line I'm going to use. So I have a greater than or equal to. The equal to ones use a solid line. Let me use a different color. Use a solid line to connect. And then greater than means I shade above. So that would be on this part of the line. Y is greater than -1. Well, y is it's the only letter. So it's a horizontal line starting at -1 across the y-axis. Greater than with no line underneath means I'm going to use this dotted line to graph. And then greater than -1 means I want to have all the numbers bigger than -1, which would be up above. Finally, number 3. I just solve for x. So let's see, I'm going to solve for y. I'm going to subtract 5x. I'll have 3y is less than -6 minus 5x. And then divide everything by 3. My equation is y is less than -2 minus 5/3 x. So my y-intercept is -2, and the slope is down 5, right 3. Okay, 1, 2, 3, 4, 5, right 3. Since my line is less than, there's no line under the inequality, which means I have to use a dashed line to connect those. And less than means I shade underneath or below the line. So that's what the solution set is. All right, there's a lesson 2, which will be a video for, and then there's a mixed practice with all the graphing if you need that.